Across the industry, providers are developing systems to support cable operators to create new services and to develop new approaches to existing services. In today's webinar, Step into Tomorrow Today, Deploying DAA and Virtualized CCAP Core, we are presenting a very interesting collaboration between CableLabs, Curio, Intraway, and Casa Systems that solves a primary use case for cable operators, namely efficiency and economical deployment of gigabit broadband. First, we will hear from Curio's director, Robin Koo. Robin will guide us through several megatrends shaping the cable industry and give us a quick overview of our collaborative POC. Then we will pass the baton over to Diego Ambul, Intraway's product manager, who will take us through Intraway's symphonic orchestration engine's role in making DAA and Visual CCAP easier to manage, configure, and adopt. Finally, we will hear from Sudhir Krishnan, a lead architect at Casa Systems, who will take us into specifics of their Remote 5 node and the Visual CCAP core. A little housekeeping before we start. If you have any questions during the presentation, you could type them in the question box that is located in your GoToWebinar control panel on the right of the screen. We will answer as many as we can during their Q&A session today. We will also be recording this webinar to share with you afterward, as well as the presentation. We do have a lot to cover in the next hour, so let's get started. I will turn it over to Robin.
All right, thanks, Ramon. Robin Koo here, and I direct the Curio NFV Interop Lab at CableLabs. Our lab is focused on interop testing for SDN, NFV infrastructure and components, and also on the integration of proof of concept systems. We want to show how new technologies, especially virtualization technologies, are being applied both to existing use cases and to new use cases, and also to provide some level of validation that systems are fit for purpose. So as the integrator for this project, it's my pleasure to introduce the solution partners and to give a brief overview of the system before my colleagues dive into the specifics. And I'd like to start by considering three technical trends that are combining to reshape networks and services. And those trends are virtualization, convergence, and edge compute. Virtualization, of course, is the transition of network functions from appliances and purpose-built hardware towards software applications that run on standard servers. Convergence is the ability to combine various types of access networks, e.g. DOCSIS HFC, Wi-Fi, LTE 5G, onto the same network core. It's not necessary to operate 3 or 4 separate networks. It's now possible to operate a single virtualized network core with various access networks facing the customer. And then finally, edge compute is the notion that nearly unlimited compute, storage, and network resources can be packaged up into almost any form factor and deployed anywhere in the network, from the core to the edge to the customer prem. And this gives operators unmatched capability to distribute intelligence throughout the network and therefore deploy new applications that can take advantage of such features as ultra-low latency, distributed data processing, and copious levels of compute resource. Next slide, please. So today, we're looking at an example of a system which solves the big money use case for the cable industry. As Ramon said, it's the efficient and economical delivery of gigabit broadband. So operators are finding the DOCSIS distributed access architecture is a key enabler for gigabit broadband. R-PHY nodes combined with the CCAP core are an extremely efficient and flexible strategy for extending the network farther afield and for bringing those higher speed connections to their customer base. And in order to implement distributed access architecture, you need 3 elements, and those align very closely with the technology trends that I just mentioned. So the center of DAA, of course, is a virtual CMTS, and in this case, it comes from Casa Systems. Casa R-PHY nodes are distributed out through the network, close to the customer, and this achieves very fast, very low latency connections while reducing space, power, and cooling costs in the head end. The RFI nodes are provisioned to a CCAP core, and in this case, it's a virtual CCAP core, and that gives all the advantages of faster update and development cycles, scalability, and flexible placement of network resources. Casa Systems has very deep experience in hardware-based CMTS platforms, and they're moving very quickly to take advantage of virtualization by retooling their CCAP core as a software application. Next slide, please. So here's a system diagram, and you can see Casa at layer 0 with the RFI node, and then at layer 4 with the virtual CCAP. At the top layer, we have orchestration. In production and deployments, it's absolutely required that you have automation. It's not practical at any scale of deployment to manage network elements or operations by hand. Intraway is our webinar host, and they have extensive experience in automation and orchestration of back office and operational support systems, and they've applied that expertise to orchestrating Casa's virtual CMTS system, and that provides the critical path capability of management and control for this system. Then finally, at layers 2 and 3 from the bottom, we show the cloud infrastructure, and these are servers and then the software that hosts the vCCAP core or any other VNF. This network function virtualization infrastructure is what enables deployment of any virtualized network function, and that is the beautiful thing. Once the infrastructure is in place for the first use case, in this case DAA, other use cases can run on that same infrastructure without significant modification. And this paves the way for the convergence that I mentioned earlier, and also for new service possibilities. So here in this stack, we're showing two different systems, one on the left and one on the right, on the right-hand side of the slide, left in pink and then right in blue. Why are we showing two different systems? And that's because in software, there's always a choice between building from scratch or buying off the shelf. Pros and cons for both, and it ends up being a business decision. But we're showing that both scenarios are achievable with this system. The first system on the left is running OPNFV OpenStack, and that's an open virtualization platform. And the stack on the right is running Wind River's Titanium Cloud, and this is a fully vendor-supported virtualization platform. Intraway's Symphonica Orchestrator and Casa's Virtual CMTS can run in either environment, and therefore operators have the very important ability to choose whether to build or whether to buy a solution. And the last thing I'd point out is at the hardware layer, server design is evolving. Transistor densities continue to rise, and every year servers have more power and smaller packages. Here we have two examples of very high density, very scalable, and very powerful server platforms. The SimCloud 2029 from Contron AG and the MicroCloud 4015 from Aparna Systems. At 2U and 4U respectively, these are powerful enough to run data center workloads, and they're small enough, compact enough to fit into a wiring closet. And it's this level of miniaturization that enables extremely flexible deployment of resources in the network. Intelligence can move as close to the edge as needed, and that's what opens up whole new classes of service opportunity. Examples could be things such as data processing for the Internet of Things, better distribution of security controls, network and security monitoring, application of artificial intelligence and ML algorithms at the edge. And all of these lead to possibilities for such things as better home healthcare, smart cities, autonomous vehicles. The list of possibilities is as long as the creative imagination would like to make it. But we're going to pause on the future for just a moment and focus back on today's use case, which is, of course, DOCSIS distributed access architecture. We have a poll question coming up, and then we'll hear from Diego Ambul, Senior Product Manager at Intraway, and he'll take us through the orchestration and management layer of the system. Robin Koo, Curio Interop Labs, back to you, Ramon.
Thank you, Robin. It was informative and very interesting. So now we have the first poll question of the webinar. We'll have a minute to get everyone's input. And the question is, what are your plans regarding the deployment of Virtual CCAP and DAA in general? You could select your answer by clicking directly on the option on the screen. So while we wait here, Robin, what do you think as an industry we are today?
Where are we as an industry today? We're in the throes of migrating into a virtual world, and really, as a cable industry, beginning to grapple with the questions that come along with how do you begin to deploy virtual network functions on a virtualized core. It's a long process. It's a long journey, and I think that many cable operators are really at the beginning or somewhere down the road in deployment of virtualization.
Excellent, excellent. So let's see what our audience have to say about this. And let's see here. So 50% of you shows that lab testing is being analyzed. So, wow, then followed by not planned at all. So what do you think of that, Robin?
I think this shows that there is a quarter of respondents that don't have anything planned yet, and 75 that are in some stage of either analyzing, testing, or deploying. There seems to be very strong impetus in the industry to seriously look at virtualization use cases like that for distributed access architecture, virtual CCAP on with RFI nodes, simply because the economics of reduced space power and cooling in the head ends, plus the flexibility of deployment, plus getting away from very long update cycles for hardware-based components, those benefits are very compelling.
Excellent. Thank you. Thank you for that analysis, Robin. Now let's hear from Diego Ambul from Intraway. Good afternoon, Diego.
Hi, good afternoon, Ramon, and everyone. Thank you for the time. And also, I would like to thank Robin for the introduction, the great overview he gave us. It's been a very interesting experience working with CableLabs, Curio, and Casa in this POC. Now, I'm going to dive into Intraway's contribution to this project. Here we can see all the elements in the POC. And in the first step, now going to the flow itself, we can see the virtual CCAP Tosca profile is configured in Symphonica, that is Intraway's service orchestrator. Symphonica then invokes Casa Virtual Infrastructure Manager, VIM, and sends the Tosca profile through an API. The VIM executes the onboarding of the virtual CCAP instances that are the control plane and the data plane. Following the onboarding, in step 2, we execute the initial configuration of the virtual CCAP using netconf. This initial configuration was previously set up in Symphonica through a BPM flow. The orchestration engine provides the automation of the virtual CCAP fulfillment process that will execute the following configuration steps: the IP bundle setup, the RPD configuration. It will enable and configure the RPD, QAM, and OFDM channels to enable them and set parameters such as the frequencies and the modulation profiles. Then the service group creation takes place, the MAC domains configuration, and finally the interfaces association. Once all these previous steps are successfully executed, the DOCSIS 3.1 cable modems connected to the RPD are registered in the virtual CCAP using the OFDM channels and get online. From a CPE connected to these cable modems, you can verify up to 1.5 gigabits per second traffic through a speed test. At this point, we configure the virtual CCAP using netconf, and we can reuse the same VPN flows to configure a physical CCAP using CLI, for example. The third step was out of the POC scope, but will be used to implement the VPN flows that configure the additional network elements that are part of the solution, such as the radio server for RPD authentication, the DHCP for multi-core support configuration through DHCP options, the switch for VLANs configuration, and the TFTP for firmware upgrades. So let's go to the next slide, please. In this slide, we will see a real use case based on the POC. This use case has to do with the bottoms-up provisioning of the RPD using a field service tool from Intraway called T-Wizard. In the first step, a work order is generated usually from the CRM or by a manual process. In the second step, the field technician receives the work order and executes the installation of the RPD. In the third step, after installing the RPD, the technician scans the RPD MAC. At this point, the fourth step takes place and T-Wizard sends the scanned MAC to Symphonica to execute the fulfillment of the RPD in the virtual CCAP. In step 5, Symphonica executes the provisioning flow, verifies and validates the information, prepares the topology and the nodes to be configured, and executes the flows and commands to the network elements. In step 6, Symphonica informs T-Wizard app that the installation was successful and reports the environmental and optical levels to generate a birth certificate of the RPD installation. Finally, T-Wizard closes the order by saving the birth certificate, the RPD geolocation, photos of the installation, and any additional comment that the technician wants to add for the installation record. So let's go to the next slide, please. Intraway Symphonica orchestrator solution offers northbound TM Forum standard APIs to receive orders that will execute BPM flows for multiple use cases. Some of these use cases are the VNF activation, including virtual CCAP onboarding, initial configuration, and network element configuration, as we saw in the POC, but also other use cases such as activation of GPON, DOCSIS, packet cable, LTE, and TV services, between others. Business services activation, such as direct internet access, corporate telephony, business services over DOCSIS, SD-WAN, and others, and legacy systems orchestration. These BPM flows support dependency between other orders, validations, inventory lookup, and partial and full fallback between other functionalities. Symphonica Orchestrator supports the abstraction of the BPM flows for the resources where they will be executed. This way, the BPM flows are executed using connectors that support different protocols depending on the network element's capabilities. The different components of Symphonica are aligned to the entities and domains defined in TM Forum Framework X. And Symphonica is an open source based solution with standard APIs and multi-protocol connectors that simplify the integration with different network elements and NMS. So next slide, please. In the last slide, in the next slide, we will see the multi-level orchestration of virtual infrastructure, virtual network infrastructures. In general, distributed access architectures such as remote PHY, remote MAC-PHY, virtual RAN, small cells, and others present several challenges related to the VNF provisioning and elastic management that will enable dynamic services provisioning and assurance plus fulfillment closed loop. To achieve these goals, more network elements and remote devices need to be orchestrated, fulfilled, and assured in both the virtual core and the access network. This is the main challenge that will help the MCOs to transition to digital service providers. So that's all from my end. If you would like more information of Intraway's orchestration engine or would like to discuss any questions, please feel free to reach out. Everyone's contact will be shared at the end of the presentation. So going back to you, Ramon.
Thank you, Diego. I think that we're simplifying a very complex process here. So now we have our second poll questions. In terms of distributed architectures, which is your biggest struggle? Again, please select the one that you think is more appropriate to you. Also, you have any questions about what has been discussed, don't forget to enter it at the bottom right side of your screen. There's a space for you to enter questions. So we'll give a few seconds here for to capture your answers. And Diego, just looking at this, what do you think would be the most appropriate one for this group?
Yes, I think that counting with the lab, with the virtualization platform, is the main challenge. That demands having the ability to share resources for different use cases. That I think is the main challenge, because there will be several areas in the companies, in the MCOs, trying to use the platform. The knowledge of the virtualization itself has to be distributed between them, and counting on the lab and counting on the resources to have that lab in place, I think, is the main challenge.
Excellent, excellent. So let's see what the audience have to say. And 40% DAA solutions for virtualized network functions are immature, and then 36% limited knowledge about virtualization alternatives. So interesting feedback from the audience. I think webinars such as this would help provide more of the alternatives with these virtualization use cases. Thank you, Diego. Now we're going to hear from Sudhir from Casa Systems. Sudhir? So it seems as Sudhir is having technical difficulties.
Sorry, I didn't unmute. There you go. Can you hear me now? Sorry about that. Yeah.
Yes.
So thanks, Robin, for laying out the importance of looking at vCCAP holistically with different server choices as well as integrated orchestration. Thanks, Diego, for walking through the RPD orchestration use cases for virtual and physical CCAP. Next slide, please. So when we look at virtualized network elements, there are multiple pieces to consider that go beyond VNF service level functionality. The solution needs to be flexible and open to support choices from an NFVI and MANO perspective. For a network function, performance, scale, and reliability are still key aspects of the functionality, even in the virtualized incarnation. Therefore, the NFVI should be chosen that enables such attributes. Service providers are looking for NFV solutions that are flexible to operate in different NFVI choices as the industry evolves and technologies mature. As we have seen with the CableLabs snaps that has shown the vCCAP and orchestration very successfully using snaps OpenStack, and now transitioning to the container-based model where Casa is aligned as well. And so, we see the industry transitioning, but from a core VNF perspective, it should remain the same. Control and data plane separation and disaggregated architecture are very key, because you want to allow independent scale of each of the VNFs from a resource standpoint. So each user plane, as you can see here, has a bunch of service groups that get mapped to RPDs. Based on the I/O, in terms of NICs installed and the processor type, the scale and performance of a vCCAP core can vary. And CableLabs has demonstrated this very well with the different hardware choices that Robin went through in the beginning. The orchestration is a very critical piece to bring it all together, and we'll talk more about it in the next slide. Next slide, please. So programmability is the key aspect. So if you look at transition to virtualization and getting to a more cloud way of operations, what you need is a high amount of automation and assurance. To this end, a standardized model for config and monitoring is very important. CableLabs has done a great job with defining an entire CCAP Yang model, which can be used for complete RPD service installation. Model-based operations gives for VNFs take operator to the cloud-based model, which enables services in a well-defined and validated manner to be duplicated across multiple devices across the network in a secure and fast manner. Today, many operators use SSH, which requires complete access to a config, which causes a lot of errors because of mistyped commands. With model-based operations, you can eliminate a lot of that. And from a stats perspective, RPDs generate a lot of stats, which need to be collected and forwarded northbound to collectors in a very standardized manner. And models are highly useful here as well to make sure that operators can get data in a standardized fashion. The end goal we're all looking at is to be truly cloud-like in operations, not just virtualization. The entire solution matters. Next slide, please. Service providers are looking to transition, but the transition has to be graceful. While DAA deployments are in full swing, the virtualization should not disrupt DAA deployments. So what you're looking at is to add vCCAP cores to augment existing physical cores and move nodes over to the VNFs as they progress. So one of the advantages of vCCAP is that the hardware can be chosen to match the kind of performance and scale as you need. And therefore, the core can actually sit in a centralized or a more distributed fashion. That's one of the advantages of this. Orchestration allows the transition to be as seamless as possible because you have the same model-based operations possible on both physical as well as virtual CCAP, which has been demonstrated by the Intraway Symphony. Next slide. So thank you for this opportunity. We'd like to really thank Intraway and CableLabs for staging the workshop and for Casa is happy to be part of it and offering up our vCCAP course and the physical course. Thank you. Thanks, Ramon, for setting up the webinar.
Thank you, Sudhir. We appreciate your input. With that, we will go ahead with some of the questions that have been posted throughout the webinar. Again, if you have any questions, please go ahead and type them on the bottom right-hand side of the screen. And the first question is, how do you see the state of adoption of virtualization in the cable industry? I think, Diego, you want to take this one?
Yes. At this moment, we are seeing several initiatives that are at different stages of maturity. But definitely the cable industry is moving forward with this as a use case that is very concrete and can be tested and can be simplified and accelerated by using the Snaps platform defined by CableLabs. And also the ability to use the same platform to add new use cases. The need is there. Customers will require dynamic services. We require zero-touch provisioning. We require to count on services everywhere. And for that, sooner or later, the service providers will need to adapt to be able to offer those services. So I think all the initiatives. I don't see anyone that is not doing at least something. And we are helping our customers to move forward in this path.
Excellent, Diego. Thank you for your feedback. Robin, anything you would like to add to this one? Robin? Or it's there? Okay, we can move on to the next question.
Okay, hey.
Yes.
This is Robin. Sorry, there was a little mute, unmute thing going on. This is the question on how are operators really adopting virtualization. And I sit at CableLabs. Curio is part of CableLabs, and the NFV Interop Lab, the Curio NFV Interop Lab, is working with both suppliers and MSOs to try to accelerate and ease adoption. And without giving away specific MSOs deployment roadmaps, I can say that there is gathering momentum in the industry, especially among the largest of the North American cable operators, to actually map out how to begin to roll virtualization into their cores in order to deploy DAA. There's not a large operator that's not actually either in process or trying to figure out how to begin. So does that answer the question from sort of an overall industry adoption point of view? Yeah. Okay.
It does. Thank you for your input, Robin, and thank you, Diego. There's another question was posted here. What other virtualization use cases are available, and can they be executed in the same platform? Robin, you want to start with this one?
Yeah, sure. That would kind of be like, what are the VNFs that are available on the market? And so we've been doing a lot of work over the last couple of years in the Curio NFV Interop Lab, doing precisely this work of hosting proof of concept systems and showcasing them at industry events, and really kind of taking a look at what is real versus what is kind of aspirational. And so the deployable VNFs that we've seen in the Curio Interop Lab to date have been VNFs like SD-WAN, software-defined wide area network. We've seen various vendors coming in with that for firewall, software firewall. We've seen virtual radio access networks. Casa has a vEPC. They've got a vWAG. They've got the mobile core network elements. We've got content delivery network edge routers here in the lab. We've seen orchestration from both Intraway and Amdocs. We've got a couple of projects in process right now. One's around software routers, and that's with Lumina, and then another one around proactive network maintenance statistic gathering with a new company called Mutable. So there are real solutions. There are commercial VNFs available, and in deployment in the industry, especially in the business or business services arena. I think lots of cable operators are either deploying or working on deployment of SD-WAN solutions and firewall. I call those probably the top two use cases, and then virtual CCAP on DAA is the one that really has a lot of momentum in the industry right now.
Excellent. Diego or Sudhir, anything to add to that one?
Yeah, I can add a piece. So I mean, just to highlight on what Robin mentioned, many service providers actually have multiple services. I mean, they have cable, they have wireless, they have SD-WAN offerings, and so what a virtualization allows them to do is to come up with a common infrastructure that allows them to run multiple services across that. So today they have to buy custom equipment for the different services, which causes them a lot of inflexibility. So what they're looking to is get to a model where they can invest in one set of infrastructure that allows them to then offer different services at different scale, which will vary based on the locations. So that's what Casa is focused on, as mentioned, with the different wireless and wireline VNFs. And working with CableLabs, which has done a good job of bringing multiple vendors together, because in the end of the day, NFV is about the multi-vendor interop, as we have shown here.
Thank you, Sudhir. Diego, anything to add?
Yes. To close, the idea, what I find interesting about all these initiatives, and also mentioning that you're using a common platform to provide different use cases. The other interesting thing about this is that you are also going to be reusing specific boxes For example, talking about a virtual firewall, a virtual router, or a virtual switch. Once you have that solution in place, you're going to be able to reuse it and reuse all your processes and the activation and the orchestration processes you already have defined. And that will simplify the deployment of new platforms. So the next step or the next time you have to deploy a new use case on the same platform, you will already have that element, the network element activation already in place, and you.
Okay, it seems that Diego got cut off, but we have another question. Hopefully,
Wait,
we get Diego.
Ramon?
Yes.
Yeah, before we move on to the next question on this question right here, let me elaborate a little bit on something that Sudhir said, and he was talking about convergence and running multiple services on the same virtualized core. And like I said, the Curio NFV lab has been doing proof of concept integration for a couple of years now, and one of the first ones that we did actually involved Casa, and we demonstrated handoff from Wi-Fi to LTE small cell and back, all over DAA architecture with a vCCAP, all integrated on the same virtualized core that was Snap's OpenStack. So we've already seen, this convergence of various access network components coordinated and synchronized on a single virtualized network core.
Excellent. Thank you for that follow-up, Robin. And we have another question. And in terms of virtualization technologies, what type of implementations do you think will gain faster adoption? vCCAP deployment as VM or container? Sudhir or Robin, you guys want to start with that?
Robin, you want to take a stab at it? I'll follow you.
Okay. All right. So VM versus container. Yes. It's for CCAP core suppliers. It's a journey to go from hardware to VM to container to cloud native. It's a development cycle, and we've been through discussions with all of the CCAP core vendors over the last 6 months, and everyone is moving from one end of that spectrum to another. So I think the answer, will operators adopt a VM solution or will they adopt a container solution, really depends on when they actually start to lab trial and field test their vCCAP, their chosen vCCAP solution. I think right now you could probably find a container-based vCCAP solution, and you can also find a VM-based CCAP solution. But as time goes on, you'll probably have more choices in containers. And of course, if you want virtual VM-based vCCAP cores, you'll be able to purchase those also. So I think it's really going to be a deployment choice on the part of the service provider. Sudhir?
Yeah. So I mean, essentially, I that's the same answer. Essentially, it's an evolution. OpenStack, ruled for many years and still rules the data center, but we see the containers have taken over with some obvious benefits. But the key thing from an NFV perspective, at least as we see it in Casa, is that you have the functional elements that need to work consistently, across a physical CCAP and a virtual CCAP. And from an operator aspect, the functional elements should be high performance, scalable, resilient. And some of the NFVI pieces should almost be another dimension across and not disrupt the main functions. So absolutely, as Robin said, later into 2019, you're going to see more containers. But then that shouldn't sort of impact some of the the vCCAP testing and validation and interop that we could do now. Like for example, the orchestration piece is going to stay the same regardless of whether we do containers or OpenStack. So it's another dimension, but it doesn't disrupt a vCCAP core from a functional aspect. That's
Yeah. Let me add something in there. Right now, if you're a cable operator and you're looking to deploy a CCAP, a virtual CCAP core, you may very well go with a VM-based solution and get comfortable with it and learn sort of the basics of managing a virtual core and managing your network components as software rather than hardware. But over time, things are going to migrate towards containers and microservices simply because of the benefits of, like Sudhir mentioned, scalability and resilience and all of that stuff. But the whole standards and specification and interface specification work is what allows these components to be treated the same, whether they're hardware-based, VM-based, container-based, and you don't need to rip everything out as software and then reinstall. So I think the standards and the specification, the interface specification work is actually pretty critical. That's what's got us to this point, and that's really going to help us going forward.
Excellent. Thanks, everyone. And we have another question that just came in. How do you convince the traditional MSO that a virtual CCAP is a good idea? Aren't they scared for these new technologies? Oof. Who wants to take that one?
Let me start. I didn't know I had so much to say in this webinar, but let me start with that one. And how do you convince a traditional MSO that virtual CCAP is a good idea? There's one answer and one answer only to that, and that is dollar signs. So
yeah, that's usually a good motivator.
And so, total cost of ownership models are what really give you a comparison between what does it cost me to deploy and operate physical CCAP cores versus virtual CCAP cores. And CableLabs is in the middle of working up TCO models in partnership with Intel, in partnership with Casa, in partnership with other suppliers that actually have experience in both hardware and the software side. And those TCO models, at least the initial incarnations of those TCO models, look very, 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 very promising. So I think as those models mature, as they take into account more data and variables, and operate over larger data sets, what we're going to see is the economic case that will convince even the most conservative CFOs that virtual CCAP is probably a very good economic bet.
Yeah, Diego, anything you would like to add? Or Sudhir?
Yeah. So again, I mean, we keep saying the same things because we are so much in sync. So it is something that has to come out of the TCO analysis, as you rightly said, the dollar sign. So it's not just technology for technology's sake. It's because you can enable something. Either you're able to enable service agility, thereby go for higher revenue. You're able to distribute your services closer to the endpoints. So there has to be enormous service delivery benefits, cost benefits that drive that technology choice. And I think the workshop on TCO that CableLabs has done has clearly shown that there is benefit to going to a virtualized model.
Yeah, if you're interested in some of the TCO, the CableLabs TCO modeling work, please get in touch with me, drop an email or something, and I can put you in touch with people that can give more information on sort of the models as they're developing.
Excellent. Thank you, Robin and Sudhir. One last question. Are there any initiatives in place in CableLabs for RPD and visual CCAP interrupt tests? So here you go, Robin, more to talk about.
One one more question. Okay. Yeah. Let me start with the specification question because it's foundational to interop. If you don't have standard interfaces, standardized interfaces, how can you test interop? So CableLabs has issued interface specs for the RFI node and the CCAP core, and as Sudhir mentioned, the information model around managing and configuring those elements. And so that's what enables interoperability between the node and the core, and also between the core and the rest of the network. And so what you end up with is a vCCAP that looks the same as a physical CCAP, both to the network and toward the RFI node. And that interoperability, those standardized interfaces and the transparency of V versus P is the key to seamless transition from physical to software components. So once you've got standards and specifications, now we go into interoperability. And CableLabs has been conducting remote PHY interops for the last 2.5 years. And we've watched RFI products mature from the very early single narrow band OFDM downstream to multiple full band OFDM downstreams, and then adding a single OFDMA upstream. And finally, we're at the stage where RFI nodes are implementing full multiple channel downstream, multiple channel upstream capabilities. So we have been conducting interops for RPD and for DAA, and we've also been very closely monitoring the maturity of the virtual CCAP implementations. So as we've been talking about, suppliers and manufacturers, they're moving from VM models to container models, and then finally they all have microservice-oriented vCCAPs on their roadmaps, and it's a long process for everyone. And I think maybe say one more thing about flexible MAC architecture. So we're working on a specification for flexible MAC architecture that lets you deploy the MAC layer of the distributed access architecture where you need it, whether it's out in the node, whether it's someplace in between, or whether it's up in the head end. And so that should cover all of the interface standards that are really necessary for the different deployment scenarios. And if you have questions on either our interop program or specification work, standardization work at CableLabs, then please just drop me a note, or you can drop into CableLabs.com and get more information than you ever thought was possible.
Excellent. Diego or Sudhir, anything to add?
Yes, from our perspective, we are working closely not only in the CableLabs lab, but also with our customers. And as I mentioned before, they are in different stages of the implementations. And the main point here is that they are making, and I'm talking about a couple of specific cases with our customers, that they are testing all their services and validating all their services in virtual CCAPs architecture or physical CCAPs and RPDs. And they are seeing as the obvious next step to go to be able to test interops. That's going to be simplified by CableLabs, but also they have internal initiatives that is not only validate the specs and the interops itself, the definition of the standard, but also how their systems and their provisioning solutions work with different vendors of RPDs connected to different vendors of CCAPs and virtual CCAPs. So it's an interesting work in progress. There's going to be, I think, a lot of movement during the next year. And things are moving also forward, and many changes in place regarding the distributed architecture. What was mentioning Robin about remote MAC5, for example, is going to be a change, and also the ability to be able to deploy multiple platforms on the same virtualization infrastructure using Kubernetes, for example, instead of OpenStack. So there are many work in progress also in the customers.
Thank you, Diego. Appreciate it. Well, I think it seems as we have covered all the questions. So to sum it up, here are a few key takeaways that we like for you to take from today's webinar. And as we are sharing these takeaways on the screen, I would like to see Robin, Diego, and Sudhir can give us a quick summary or your key takeaway from this webinar and moving forward in 30 seconds or less each, please. Start with Robin.
Yeah, okay. So my 30-second last minute takeaway is that virtualization is like applying the OSSI model to the network, right? It's layering the whole network up into different segments so that you can develop and evolve different segments without interfering with the other segments. And it really opens up a whole new approach to how we build and deploy networks and to the things that we can do with them. I think the future looks really, really bright. That's my 30 seconds.
Thank you, Robin. Diego?
Yes, I totally agree with Robin. I think there are many challenges in place. And what makes this more interesting is this kind of initiatives where we can see a live POC with real use cases in progress, and we can see how we can walk through the evolution and then make the changes real. And also be able to see that this is not only a POC, that this is implementable, this can be deployed in any service provider that want to test and verify the platform. That makes the difference because closes the gap between a simple presentation and a real use case in place. And I like the challenge, and I think the complexity can be undertaken and can be worked through by making real these initiatives.
Thank you, Diego. Sudhir?
Yeah, so I agree with both what Robin and Diego said. I mean, I think for me, what this workshop has highlighted is the importance of standardized model-driven operations. I mean, through standardized model-driven programmability, you can basically enable services very seamlessly across physical and virtual CCAP. And I think that's going to be a key enabler for handling some of the complexity that is built into sort of transitioning from a physical to a virtualized CCAP core.
Thank you, Sudhir. So with that, we're coming towards the end, and before we put up some announcements, I would appreciate towards the end we're gonna have a quick survey for you to complete, so it helps us promote more webinars and come up with more content to help you in your future endeavors. But I want to thank everyone for being here with us today. Here are a few announcements from Kirio, Intraway, and Casa. To request a demo or a meeting, you can fill out the form on the webpage on the screen, or just shoot me an email. We'll be happy to set up a live demo or visit you at your location. Also, CableLabs is hosting a series of Interlab events in January 2019. For more information, you can visit the events section of their website. And to learn more about Casa Systems, please visit their website on the screen. Don't forget that we are sharing this webinar and the presentation with you. Feel free to share this webinar with your peers. Be on the lookout for our email going out tomorrow. And also stay tuned for our upcoming 2019 events. It's going to be an exciting year. That is it for us today. We thank you for investing an hour of your day with us, and that you found this information very valuable. We look forward to seeing you next time. Thank you.